Have you ever looked at the price of store-bought dishwasher pods and thought, man, there has absolutely got to be a cheaper way to do this? Well, today we are going to find out. Welcome to The Explainer. We're taking on the ultimate DIY household challenge, figuring out if there's an actual, effective, budget-friendly alternative to those pricey little commercial packets. But listen, we aren't just going to mix some random powders together and cross our fingers. We're actually diving into the chemistry of what makes dishes sparkle, testing 3 specific homemade methods, and finding out what really works.
It's a totally fair question that we've all asked while restocking our cleaning supplies. But here's the thing that most DIY tutorials conveniently leave out. A lot can actually go wrong. If you use the wrong ingredients, your tablets might crumble into a sad, powdery mess. They could leave a gritty residue all over your nice glassware, or worse, completely neutralize their own cleaning power before they even hit the water. And if you make a critical error with your soap choice, you might end up turning your kitchen into a giant bubble bath. We definitely want to avoid all of that. So, let's get right into it with part 1. The chemistry of clean, specifically washing soda versus baking soda.
Before we even think about combining ingredients, you really need to know that you can't just substitute one white powder for another and expect the same results. Take baking soda, or sodium bicarbonate. It has a very mild pH of around 8. It's totally safe to eat, acts as a gentle abrasive, and it's great for deodorizing. But then you have its heavy-duty cousin, washing soda, or sodium carbonate. Notice the missing hydrogen atom in its chemical formula? That one tiny difference is actually massive. Washing soda has a highly alkaline pH of around 11. Now, if you remember your high school chemistry, the pH scale is logarithmic, meaning a pH of 10 is 100 times more alkaline than a pH of 8. So washing soda at 11 is vastly more powerful. It's a caustic base that aggressively cuts through tough fats, heavy grease, and those stubborn acidic food stains. But because it's caustic, it is absolutely not edible, and you should definitely wear gloves when handling it to avoid skin irritation.
Now for part 2, kitchen alchemy, making your own washing soda.
If you can't find washing soda at the store, no problem at all. We can easily make it using a cool chemical process called thermal decomposition. You see, baking soda is actually quite unstable at high temperatures. When you introduce enough heat, the compound literally breaks apart. It strips away water vapor and carbon dioxide gas, which just escape right into the air, and what gets left behind is our highly alkaline, grease-fighting powerhouse, sodium carbonate.
Here's exactly how you do this at home. Just spread a flat layer of regular baking soda onto a shallow metal baking pan. Quick pro tip, do not use aluminum for this, as it reacts with the soda. Next, pop it in your oven at 400 degrees Fahrenheit, that's about 200 degrees Celsius, for 30 to 60 minutes. You're going to want to stir it every 10 minutes or so, and you can actually watch the chemistry happen. Baking soda is powdery and naturally clumps together, right? But as it converts, the texture completely changes. It becomes dull, kind of grainy, and stops clumping entirely. Once it looks and feels like flat, dry sand, boom, you've successfully created washing soda.
All right, moving on to part 3, the test kitchen. We are testing 3 DIY methods.
It is time for the practical experiment. To keep things scientific and fair, we're judging every single batch against 4 very strict evaluation metrics. Number 1, ease of making. Number 2, how well do they hold together when popped out of a mold? Number 3, how do they actually perform in the dishwasher? And number 4, do they leave any chalky or gritty residue behind on our dishes?
Method number 1 is a classic combination. We're using that powerful washing soda we just made, mixed with some baking soda for deodorizing, plus some coarse salt and citric acid to help tackle mineral deposits. The goal here is to dry mix these powders and then really slowly add just enough liquid binder so the mixture feels like damp sand. Then you pack it incredibly tightly into a silicone mold. The tighter you compress these, the better chance they have of staying in one solid piece when they dry out.
Now, as we move on to our liquid binders, I've got a quick question for you to think about. What happens when you mix an acid, like vinegar or citric acid, with a strong alkaline powder like washing soda? If you ever made a baking soda volcano as a kid, you already know the exact answer. They neutralize each other, releasing a ton of carbon dioxide, lots and lots of fizzing.
Which brings us right to method 2. Here we use a very similar dry base, but we're using distilled white vinegar as our liquid binder. And because of that chemical reaction we literally just talked about, this is where things can get incredibly tricky. If you just pour the vinegar in all at once, the whole bowl will erupt into a fizzing, bubbling, mushy mess, and you'll neutralize all your alkaline cleaning power before it even reaches your dishwasher. So you have to add the vinegar incredibly slowly. I mean, just a few drops at a time, allowing that reaction to settle until it's just sticky enough to mold.
Finally, method 3 leans heavily on citric acid.
This recipe is specifically formulated as a secret weapon for households dealing with hard water. The citric acid is fantastic for cutting through those stubborn mineral deposits that leave your glasses looking super cloudy. But again, moisture control is key here. It needs to be just damp enough to mold, but dry enough so the tablet doesn't prematurely activate while sitting on your counter. After molding all 3 batches, we leave them in a dry place, sometimes overnight, sometimes for a few days, until they are rock solid.
Which leads us to part 4, the results and our final verdict.
All right, the wait is over. The tablets are completely dry, and it's time for the ultimate test. We loaded up the dishwasher with similar loads and ran them all in the exact same settings. Oh, and a massive tip before you try this at home, never, ever confuse machine detergent with regular liquid dish soap. Unless, of course, you actually want to turn your kitchen into an overflowing foam party. So how did our DIY pods translate to real-world results? Let's see how they did. Method 1, the washing and baking soda mix, was great for general cleaning, but it absolutely required super tight compression to prevent crumbling. Method 2, the vinegar binder, was fantastic at cutting tough grease, but man, making it was highly tedious because of that fizzing reaction. Adding a millimeter too much liquid ruined the batch, turning it into mush. Method 3, the citric acid-heavy tablet, was the undisputed champion for hard water, leaving glasses incredibly spotless, though finding that perfect moisture balance to bind it was definitely tricky.
So, you're probably wondering, which one is the ultimate winner? Well, the truth is, the best recipe isn't necessarily the one with the most complex ingredients. A true winning pod must form a solid tablet. It has to store on your shelf without turning back into dust. It needs to dissolve properly during the wash cycle instead of leaving grit. And, obviously, it has to clean effectively. But the absolute most important thing? It has to chemically align with your specific dishwasher and your home's unique water supply. What works perfectly in a home with soft water might have hard water spots everywhere in another house. Because of that massive variability, here is the single best piece of advice if you want to tackle this. Start small. Please don't go out and buy bulk ingredients to make an entire year's supply on your very first try. Make a tiny test batch. See how the chemistry reacts with your plates, your machine, and your tap water. Test it out, adjust your ratios, and only then decide if making these pods is worth your time and effort in the long run.
And that wraps up our deep dive into the science of homemade dishwasher pods. We've seen how pH levels matter, how thermal decomposition turns everyday baking soda into a heavy-duty cleaner, and how the right liquid binders make all the difference. So, I leave you with this. Are you ready to turn your kitchen into a test lab and try this practical science for yourself? Keep experimenting, keep learning, and thank you so much for joining me in this explainer.